and I see so many of us without books. How lovely. You turn your knees around, face this way. You look at me, you think it's more important to look at Casey than it is to pay attention in class.
I'll look at it.
Sounds like you got
Yeah, the problem is,
hey, you're silent.
I said you can't see what we're looking at, so you probably want to pull up this page sometime. On page 368, it shows you all the different equations and the different graphs you get. It depends on, the top ones form what are called circles. If it's a circle, it's always going to have an equation of just some number times cosine or some number times sine. That's going to get you basic circles. You'll notice right beside it are what we call lemniscates, and their equations are a little bit different. What do those graphs look like? Yeah, they look like infinity signs. Exactly. What do you notice about their equations? They have squares on them. So if you see squares on them, you know you're going to get the infinity-looking graph. So that's what those tend to do. And this case has a double angle. Okay, what we just drew is a lemicon. They are probably by far the most common. A lemicon? They look like a circle, except they have a dent. Some of them have their circle with just a tiny bit of a dent. And in our case, we got one. Some of them have a really sharp dent, or in our case, we got one that actually has the full loop inside it. Okay, you'll notice the equations are always some number plus some other number times sine or cosine. It depends on whether the first number is bigger than the second number, if the two are equal, if the second number is bigger than the first number. If you look at the formulas in the book, depending on the size of those numbers, it tells you which shape you're going to get. We aren't going to get that serious about it, that you have to know all that.
Since our number was smaller than that other number.
Yeah, we did 2 plus 3 cosine. Our first number, A, was smaller than the second number, so therefore we got one that had the complete loop in the inside of it. So if you really want to become an expert on these, you can learn those rules and know instantly when you look at it which shape you're going to get. Okay, the ones I love the most, and you get to do one of these on your assignment, I love the rose curves. They're so pretty.
Pretty, but they don't look fun. Where's the umbrella?
They're not.
We've established this already.
If you do the rose curves, you'll notice that the formulas all have, once again, sine or cosine primarily. They are multiple angle formulas. It might be 2 theta, it might be 4 theta, it might be 8 theta. Depending on what that number is, it has an impact on whether you have a flower with 3 petals, 4 petals, 8 petals, whatever. It's not totally that we actually notice. The one when n is 4 has 8 petals.
Well, maybe if it's odd,
But the one when n is 3 is 3 petals.
So, like, maybe when it's odd, it is.
Okay, when you go to draw one of these, when you're doing a rose curve on your graph paper, you need to connect the dots as you go, because it will not make the rose curve. It won't do a petal, then a petal, then a petal. What it does is like the way you make a star.
It goes like a star.
It'll go here, and then it'll loop around over here, then it'll come back over here, and then it'll loop around. It loops around in several. So you need to connect your dots as you go, or you'll get lost later trying to connect them if you wait till the end.
So I guess it's going to take like an hour to draw.
No, it won't. You have to plot as many points as I just plotted there. How hard is it?
Oh.
You are the biggest whiners ever. Your calculators do 90% of this for you. This is pug. Compared to how we used to do it, this is nothing. So don't whine at me about it.
It's like saying
It's nothing. You get the data out of your calculator.
That might be nothing but to.
You're lazy. That's the problem. My point was made right there.
Yes.
This is a no big deal thing. But you don't get good at understanding polar coordinates, so you've plotted some polar coordinates. I'm saying, yeah, okay, this assignment today, if you can't do this assignment today, you're totally completely messed up for next class. and then you will flunk this quest.
That's like stabbing somebody and asking them not to believe.
What?
Trying not to laugh.
I'm just mystified. Okay. I'm done with white backgrounds now. I don't want to teach the rest of this on white. I'm in the mood for spring.
And you got that on your taping too.
I think they all know what that means.
You realize you're still recording, right?
Yeah, I do realize I'm still recording. Okay, so now,
After a lot of video editing.
not going to happen.
That wasn't as bad as last year, just came before.
That is not going to show up either. I need something dark. I shouldn't have picked this color. Nothing shows up. Guess we'll go this way. Okay, your main challenge of today is to figure out how do you convert back and forth. If I give you one set of coordinates, how do you convert to the other set of coordinates? Okay, you will do this by hand, and you will show me work.
No. That sounds like a threat.
Okay, so we have rectangular coordinates, we have polar coordinates. We know rectangulars are our good old basic XY that you've been doing for years, and polars are theta. We got that part down. Okay, what I want to do is I want to give you the coordinates in one form and have you switch to the other form. How you get back and forth between forms. Okay, you already know this. This is trig you already know. This is just common sense trig. All we have to do here. So, and I'm actually going to give you, I can give you nice coordinates that will, some of these will be nice coordinates and they'll be special angle values and it'll all come out very pretty, or sometimes it won't. So we just have to live with that. So we're going to start with a nice little coordinate of 2, -3. How do I figure out? We know 2, -3 is over 2, down 3, so you should be able to estimate that it's what kind of an angle. Yeah, it's got to be probably somewhere, it's definitely got to be between 270 and 360 for sure. But you know automatically if you plot those coordinates, we're over 2, we're down 3, you don't need to plot this exact, but you do need to get ballpark-ish. We know we're over 2, down 3. I'm trying to figure out then what is the radius and the angle to end up at the same place. Okay, so how are you going to get the radius? Yeah, you're going to do Pythagorean theorem. So yeah, that's not going to be a big deal. 2 squared plus -3 squared has got to equal the radius squared. Okay, 4 plus 9, we got 13. So r is really an ugly square root of 13. That's not going to break down. Okay, nobody said r had to be a pretty number. So you know how long r is. You also have to know what angle, what direction am I going in. Okay. So how am I going to find what angle this is? I am going to have to use a trig function formula because this is not, that's not a nice easy Pythagorean triple. It's not going to come out to a nice special angle value here. So you want to use, if at all possible, use the numbers they gave you because they have no rounding error in them. They haven't been calculated. So what trig function could we use that would use this side that has 2 and the side with -3? What trig function is that? That is opposite and adjacent, which means we're using tangent. So you're going to go, oh, I know the tangent of this thing is opposite over adjacent. All right. Since 3/2 is not a special angle value, how are you going to get the angle out of your calculator? Thank you. All right. I want to find an angle. Hit inverse trig function gives me an angle. So yes, you're going to say do inverse tangent. Okay, you really don't need to type the negative in your calculator because you're just after the reference angle. But you're going to do inverse tangent of 3/2, and your calculator is going to spit back at you 56.3. Okay. Is that the direction we're actually going in? because this is polar coordinates. You got to be going from 0 to 360. We're clearly down here in the fourth quadrant. That is not that's not 56 degrees in direction. So yeah, you just know the reference angle is 56.3. How are you going to get the actual direction you're going in? Yeah. Since we're in the fourth quadrant, we're going to go, what's 360 minus 56.3 to get the actual angle, which is going to be 303.7. Okay, when you subtract it. Now, since they're going to ask you for polar coordinates, what does your answer have to look like? So it wants you to write your answer as a polar coordinate. It's got to be written, your answer has to be written as r comma theta. It has to be as a polar coordinate there. So your answer in this case, r is square root of 13, and your angle is 303.7. So as far as the final answer, if they say they want the answer as a polar coordinate, you must give your answer as a coordinate. Parentheses matter. I'll get you for half a point on the quest every time you don't put them on. The parentheses matter. It's not a coordinate until you put those on there. Okay. So now we can turn that into a basic formula though, and I know I asked you for these formulas on your journal. If you are converting rectangular coordinates to polar, how did you guys just find r? Pythagorean theorem. So we did x squared plus y squared, and then we had to square root it. So there's technically a formula for how you find r. And we just found the angle by setting up what? How did I get that angle? I did an inverse trig function. Okay, you want me to write it as an inverse trig function, or do you want me to write it as tangent is? And usually most years I just write it as you set up tangent of, you have to set up tangent and then you have to do inverse tangent to get the actual angle. But you're going to have to set up, it'll be tangent every time because you're always going to know x and y. So that's how you go one to the other. I want to point out, however, there are certain problems that are super de-duper pud and you don't want to go through all that work. You want to use good old basic common sense. If I gave you the coordinates negative 3, 0, okay, you should be able to instantly tell me the polar coordinates of that one without even doing because where are you at if you're at negative 3, 0? You're 3 over, left 3, up 0. So, okay, what's the radius and what's the angle? The question is the radius. What angle are you going to use? If you're using 180, then what the radius is moving in that direction, so the radius would be positive 3. If you're going on the 180 line, you would go positive 3 in that direction. Okay. If it's sitting on a quadrant line, there is no work. Just look at it. Common sense it.
You should give us one of them on a test.
I probably will. But anytime you know you're sitting on one of the quadrant lines, there is no work. It's just think about it. Okay. So now I want to go backwards. How do I go from polar to rectangular? How do I get the other way? And this is also easy once we figure out the quickie little formula that does it. Okay. So I am going to give you the polar coordinates 10, 210, 210 degrees, and I want you to find me the rectangular coordinates that end up in the same spot. So you got to find me x comma y. Every single time, as you should have learned by now in trig, you need to draw the picture. Every single problem, draw the picture. Where would 10, 210 be? It would be in the third quadrant. And you know what length?
The radius is 10.
You know the radius is 10, and then of course we can put our triangle on there. You're trying to find side x and side y.
You gotta do it backwards, so you gotta do the tangent or whatever.
Okay, and realize, you know the angle technically we actually know the whole angle is 210 degrees to that point. But I'm actually going to have to, in the actual triangle though, yeah, isn't it a 30-degree reference angle I'm using then? Yeah. Okay, so we have to set up a trig function. We know the angle, we know one side, we know the hypotenuse. So if I want to find x, which trig function should I use? Yeah, if you want to think of it as adjacent and hypotenuse, or you want to think of it as, x and r. Yeah, it would be cosine, wouldn't it? So cosine of that 30-degree reference angle would be x over, in this case, 10. How are you going to solve for x? Yeah, multiply by 10. Now, this one, if it's a special angle value, I expect you to use a special angle value. If it's 30 is a special angle, so we're going to fill in the value. If it's not, if that was 50 degrees, you would just throw it in your calculator and get a decimal. But since we actually know this one, what is the cosine of 30? Yeah. It is square root of 3 over 2. So simplified, just 2 cancels into 10, and so x is 5 times the square root of 3. So now do the exact same thing except solve for y. What do I have to change to find y? You could. I don't recommend the Pythagorean theorem because of the fact this came out exact, it'd be okay. But if this is a rounded answer, using the Pythagorean theorem gives you an even farther off answer. So we would have to use sine. And actually you'll notice it's going to be the exact same thing. It's going to come out 10 times the sine of 30. Sine of 30 is a half. Oh, duh. Why are we wrong on both of them? Negative. Why? Also, our trig class, we're in the third quadrant. That should have been negative. So, x is clearly going left. We have to have a negative answer. Y is clearly going down. We have to have a negative answer. Yeah, shoot. You can do them with radians. They typically don't do a lot. Usually polar is done in degrees. Primarily because it's a navigation thing and we don't navigate in radians. But yeah, you could do this in radians and it would be perfectly fine. It would work perfectly fine. So now, as far as a final answer though, what do I want? I shouldn't have boxed that because that's not my final answer. You could have, like I just said, if they're exact numbers, you could do Pythagorean theorem. But if this is at special angles and you've gotten a decimal value out of your calculator, you don't want to do Pythagorean theorem because it's going to give you error. But plus, I'm about to shortcut this in a second, and you're not going to want to mess with the Pythagorean theorem as soon as I shortcut it. Thanks. Let me write this answer. So your answer has to be a coordinate. So you still, when you get done, you have to say, oh, my coordinate is negative 5 square root of 3, negative 5. You have to get your answer in as a final answer. If they're asking for coordinates, you need to write your answer as a coordinate. Okay, let me stop it and then I'll...